Good morning, good afternoon, and good evening, everybody. My name is Mike Thompson. I'm a Senior Product Line Manager here at Xilinx. Today we're here to talk about the latest Versal ACAP, that's Versal Premium. Welcome to OFC 2020. This time we're doing a virtual presentation. I'm sorry that we can't be in the same room as each other. I really wish we could be. Nonetheless, we'll move this presentation to virtual and look forward to engaging with you on Versal Premium soon. So there's many forces putting pressure on core networks and core data centers today. Comes from a really wide variety of applications, from the enterprise to video streaming to IoT, as well as our smart devices. Now, nominally, the bandwidth growth that we see year over year is growing at a 51% CAGR. That's a doubling of bandwidth every 2 years. And having been in the industry for a long time, keeping pace with that amount of growth has been enough of a challenge for us. With the advent of 5G, where we have an order of magnitude greater number of devices, as well as an order of magnitude higher bandwidth per device, we're looking at least at 100 times increase in bandwidth requirements coming from just 5G. So all of that puts a tremendous amount of pressure on the core. And today, when I'm talking about core, I'm talking about core networks, as well as the core data centers in the middle of those networks. This is a look at a few metrics that represent that pressure on the core and what needs to be done for the next generation core. Looking at core network growth, today we're already forecasting a 313% CAGR on core networks just to accommodate the additional bandwidth of 5G. So tremendous amount of growth just in that segment of the market. And given that telco equipment providers tend to have a 2 to 3 year design cycle from concept or execution commit to a production qualified and deployable platform, that's generally 2 to 3 years. So if you look at 2023, we've got a $3.5 billion spend going into the core. The first movers in these markets tend to capture a significant amount of market share. So if those providers want to play in that growth in spend, they have to start designing now with a 2 to 3 year design cycle. An interesting trend we're seeing this time around is what are the highest priority functions and features that network operators are looking to roll out? Traditionally, those highest priority features have been performance, usually performance boosts, expansion as in footprint expansion, and cost, usually cost optimization. This time around, security and analytics have risen to the top of the pile in terms of priorities of features to roll out. And so any next-gen solutions need to be able to address security and analytics. And then finally, as we've all heard probably many times, about the end of Moore's Law. That means the relative CPU cycles per server are no longer increasing node to node as much as we've been able to depend on in the past. At the bottom of it, this really means that transistors aren't getting any faster. Now, at the same time, there is still an exponential growth in bandwidth consumption. Bandwidth per port is still increasing exponentially. So that creates a gap between compute capabilities and the bandwidth that needs to be serviced. Because we can't rely on traditional node-to-node performance gains in order to be able to solve that gap, we have to do something different. I would argue, Xilinx would argue, that we need a fundamental innovation at the architectural level. And that's why we made Versal Premium the way we did. It's triple the bandwidth for the fastest and most secure networks. It's double the compute density, that's the programmable logic, for adaptable acceleration. And the adaptability there is very, very important. It's possible to deploy equipment early, and then when next generation emerging optics come out, Versal Premium will be there ready to enable them. And then on the other half of the market, on the compute acceleration side, neural network algorithms and the other algorithms that are really in need of acceleration today, they change frequently. It's a young industry. Year to year, there's a lot of changes. So their algorithms are changing on a yearly basis, at least, if not on a monthly or a weekly basis in agile development environments. So the adaptability allows Versal ACAPs and Premium to keep pace with that change. And then finally, Premium is a really highly integrated hardware-software platform. The hardware is highly integrated, and we have a robust software ecosystem to be able to address all manner of developers. So this high level of integration is really for productivity. At the end of the day, that translates into earliest possible time to market for our customers and the ability to capture revenue and market share. Versal Premium is built for many markets. Wired and data center are probably the biggest. Test and measurement is a significant market, as well as aerospace and defense applications. So Versal Premium is the newest ACAP. Xilinx has announced the names, at least, of 6 ACAP series. 2 of them have been shipping since the middle of last year, since the middle of 2019. AI Core and Prime have been shipping since the middle of last year. There's 2 lineages here. There's the AI lineage. These have integrated AI engines. And then there's the lineage that has more close parallel to the FPGAs that you're accustomed to seeing from Xilinx, with Prime being the equivalent of a Kintex, Premium being the equivalent of a Vertex, as well as HBM being equivalent to Vertex. Now, Prime, shipping since the middle of last year, is the foundation for Premium. So we're basically going to take Prime, boost the performance, add a bunch of connectivity and integrated cores, and that's where we get Premium from. So we're shipping this silicon already. As a refresher, or maybe as an introduction, what is an ACAP? And in order to illustrate that, I'm going to use the foundational series, Versal Prime. This is what we're going to build Premium on top of. So ACAPs are adaptive. They're adaptive to a diverse set of workloads. They're able to future-proof algorithms and optical standards. They are compute acceleration. They have scalar engines, which are embedded ARM application processors as well as real-time processors. They are adaptable engines. This is the programmable logic that you've grown accustomed to from FPGAs, although re-architected at this generation, as well as intelligent engines. And in this context, intelligent engines refers to DSP engines. And then it really is a comprehensive platform. It's a software programmable silicon infrastructure with a bunch of pre-engineered connectivity. We have dedicated interfaces for compute like PCIe and DDR4. Of course, there's Ethernet interfaces, a bunch of transceivers. And the platform is available at boot, something that we saw from our 16 nanometer deployments across a bunch of, especially the hyperscale data centers, is that these devices need to be able to wake up at boot time and identify themselves to the system in a very quick, short amount of time. At the bottom of it, that really means enumerate on a PCIe bus in under 100 milliseconds. And so with the platform management controller this generation, the ACAPs Premium is able to identify itself to the system right at boot time, enumerate on the PCIe bus. It can wake up the network on chip and make the external memory available right at boot time. So solving one challenge we saw from last generation. And then lastly is the programmable network on chip. This is a very high-speed, on-chip network with arbitration, quality of service, all built in order to be able to move fast, wide data buses all over the chip. And so how do we get Versal Premium out of Versal Prime? You can see these gray boxes across the bottom of the chip here. This is all the integrated IP. So what we're calling out here is what's unique and new to Versal Premium. To begin with, we have PCIe Gen5 with integrated DMA, as well as C6 and CXL support, 112 gig PAM4 transceivers, the latest and greatest leading edge transceiver technology, 600 gig Ethernet and interlocking cores, as well as 400 gig high-speed crypto cores to address the security concerns in the market today. So altogether, this is a massive amount of integration, breakthrough integration of networked power-optimized cores on an adaptable platform, and by networked cores, I'm referring to the programmable network on chip. To take a look at the scale of integration in Versal Premium, if we were to take just the Ethernet, interlock, and cryptographic cores in one Versal Premium device and implement that in soft logic at 16 nanometer on our high-end Vertex UltraScale Plus devices, that would take 22 devices to integrate the equivalent functionality. So massive scale of integration. What that allows developers to do is focus on developing their core competencies, to focus on implementing differentiating high-value logic, as opposed to spending design time on infrastructure and connectivity and cycles in the tool, closing timing. This is the fundamental innovation that allows Versal Premium to surpass the limitations of Moore's Law, the death of Moore's Law for next-gen bandwidth and processing applications. And then finally, it enables greatly reduced CapEx and OpEx. Reduced CapEx because Customers can buy smaller chips or fewer chips and reduced OpEx because all of that functionality is hardened in ASIC-like cores, consumes a lot less power, and ACAPs have really good performance per watt characteristics. So massive scale of integration. How does Versal Premium enable the fastest, most secure networks? So with the advent of 5G, we're seeing up to 100 times increase in bandwidth requirements on the core. That requires greater bandwidth density. Solutions are restricted by existing form factors, power, and materials, and the COs have limited floor space. The telco operators can't just plop down 100 more COs for every central office they have today to accommodate that 100x increase in bandwidth from 5G. A more fundamental innovation is required to accommodate that bandwidth. So how does Versal Premium deliver power-optimized bandwidth density? It really comes from a broad range of features. There are scalable transceivers from 1 gig to 112 gig. There's dedicated connectivity, hardened IP for connectivity and security functions, as well as adaptable hardware. This is the programmable logic that you would be accustomed to from FPGAs. So Premium services a wide variety of optical modules quite readily with 100 gig and 400 gig optics in the OSFP and QSFP DD form factors. We're servicing these optics today. 100 gig optics tend to have 25 gig electricals on the backside. 400 gig optics are deploying with 50 or 56 gig electricals on the backside. Next generation, for future optics, we're expecting in the same form factors to see 400 gig migrate to 100 or 112 gig electrical, and then again in the same form factor, 800 gig optics to use 8 by 100 gig electrical connections. So customers can deploy early using Versal Premium, and then when these optics finally mature and start hitting the market, they have a platform that's ready to accommodate them. So looking at the mix of hard IP and soft IP, we have in hard IP, we have a broad range of SerDes line rates, multi-rate Ethernet to cover all the standards from 400 gig down to 10 gig and beyond, inline encryption, as well as interlocking for chip-to-chip connectivity. Now on the soft IP side, the adaptable hardware is now cleared to implement differentiating high-value functions like telemetry, virtualization, packet processing, and then in particular for the security algorithms and AI ML applications, we see a lot of churn in the algorithms and the logic that's implemented for those. And so the adaptable hardware allows customers the ability to evolve with those emerging standards and evolving applications. So net, Versal Premium brings higher bandwidth density per line card. So here's the transceiver technology from Xilinx. Xilinx has a good track record over the last few nodes of bringing very high quality, very robust transceivers to market. We're bringing forward our 32 gig GTY transceivers from the last few generations into Premium. These are targeted at mainstream power optimized 100 gig interfaces. They're very multi-rate for all the standardized rates from 100 gig down to 10 gig. We could go down to 1 gig, but typically that market is better serviced by a mid-range or cost-optimized product. We perfected our 58 gig PAM4 transceivers in 16 nanometer and Vertex UltraScale Plus. We call these GTM transceivers. These are aimed at current 400 gig ramp and deployment. And finally, what is new for Premium are 112 gig PAM4 transceivers. We do see the industry moving towards 100 gig single lane optics as well as 800 gig infrastructure. 112 gig PAM4 is going to be needed for that, and so those are new. Of course, we cover all the optics that are necessary to cover the mainstream interfaces here, as well as, since our transceivers have a really robust set of features, we can cover copper cable deployments as well as backplane applications quite readily. This is what the dedicated IP for connectivity and secure networking looks like. Premium has up to 5 terabits of Ethernet throughput. It's very multi-rate, scaling through all the standardized rates from 400 gig down to 10 gig. At this generation, we have integrated and hardened the forward error correction, the FEC in Versal Premium, and the Ethernet subsystem covers a wide range of standards. Flex Ethernet, Flex OTN, eCPRI for backhaul, fiber channel over Ethernet, as well as OTN. There's 1.8 terabits per second of off-the-shelf interlocking connectivity. This again is hardened. We integrated the RS FEC for interlocking, so power optimized error correction is included. And up to 1.6 terabits per second of encrypted line rate throughput. This is a significant differentiator for Premium. It's the only hardened crypto engine in an adaptable platform in an FPGA-like device. It is built on top of an AES GCM 256-128 encryption-decryption engine and supports MACsec and IPsec. So with one platform in Premium, customers can scale from access rates through the Metro and DCI rates up into the core at 400 gig and 800 gig. So all of this pre-built connectivity enables our customers to get the fastest time to market in an ASIC class power performance envelope. So what do we do with the programmable logic now? The programmable logic is there for hardware differentiation, the ability to accommodate evolving standards even before they're finalized, as well as AI/ML applications. So this will be the highest logic density 7 nanometer platform. The adaptable engines, the programmable logic, is there for implementing novel functions like AI for network anomaly detection. This is an elegant way to do intrusion detection and malware identification by using neural networks trained to understand the nominal patterns in an enterprise network. And if there is some type of penetration of that network, if there's a bad actor on the inside, say trying to phone home to a malicious server, those network patterns will stand out from the nominal usage patterns. It's a very elegant way to get to identifying which packets bear further inspection. And then another novel application for AI in networks is for provisioning and network performance. It's possible to train a neural network to recognize the patterns and determine when there's some deviation for that. So if there's a fiber cut or a performance degradation, this network can quickly recommend the next best path through the network for a given time of day, week, month, or year, because it can recognize those traffic patterns, just like our map applications are able to do today when we're driving around and mapping our route. So this enables self-provisioning and the possibility to maximize uptime for end users. Versal Premium comes with industry-leading transport application throughput. Here we're looking at Premium versus our last generation, Vertex UltraScale Plus. It's got about 6 times more throughput than the last generation, as well as versus 2 common ASSPs on the market. This is the DigiG4 and DigiG5, so significant transport application throughput. So data center interconnect is a very hot corner of the market now. With Versal Premium, it's possible to bring a single chip 800 gig DCI solution to the market in under 100 watts. Looking at deploying 800 gig DCI in last generation with Vertex UltraScale Plus, our 16 nanometer platform, it would have taken 2 devices and at least 200 watts to support that platform. 100 watts is a rough limit that we see in the telco industry, in the networking industry, in terms of what can reasonably be cooled per device or per port. With Versal Premium, it's possible to implement the same 800 gig throughput, DCI throughput, in one device, so reducing the footprint by half, at the same time as reducing power by 60%. So that is less than half the power, half the footprint, and double the bandwidth density. And so what does that bandwidth density mean? A lot of data centers and central offices are challenged for rack space. If we take a given rack providing X amount of bandwidth, that same bandwidth can be provided in half the rack space if that equipment is upgraded to Versal Premium. And then the flip side of that is the same rack space can double its bandwidth capacity in a slightly lower power consumption. So significant improvements with Versal Premium in terms of power, footprint, and bandwidth density. So what does the product portfolio look like and how do users get started today? Versal Premium is a really broad portfolio. It ranges from a fairly modest 1.5 million logic cells, about 720K LUTs, up to 7.5 million logic cells or 3.5 million LUTs. This is a really big device. This is an emulation class size device, yet still integrating a tremendous amount of connectivity, security, and other functions. Premium has 2K DSP slices up to about 14K DSP slices. Our DSP at 7 nanometer has been enhanced. We've moved from DSP 48s to 58s for more throughput. Of course, we have the scalar engines. These are integrated ARM application processors and real-time processors. And for all of the hardened integrated IP, these are available in various counts across the portfolio, tuned to different segments of the market. So we have two kinds of PCIe. There's a highly integrated core for PCIe that includes DMA and C6. There is PCIe Gen5 by 4. Lighter weight PCIe instance. We see those being used in the communications market a lot for command and control and host communications. There's 100 gig multi-rate Ethernet, again, servicing 100 gig rates all the way down to 10 gig. We see these being used for a lot of client-facing ports. The high-speed Ethernet MACs are 600 gig Ethernet subsystems. It includes the MAC, the PCS, and the PHY. It can be implemented for standard Ethernet rates as well as channelized Ethernet rates, for example, 6 by 100 gig. There's 600 gig interlocking for connectivity and 400 gig high-speed crypto engines. So a very broad portfolio at the high end from Xilinx. So customers can get started designing for Versal Premium now. Because Versal Premium is built on top of the foundation of Versal Prime, it's possible for customers to start prototyping in Versal Prime now. They can use the evaluation kits which are shipping now. They can do chip-down designs with the devices that are shipping now. And if they do a chip-down design, they have the ability to do pin migration from Prime to Premium, so they can drop in a Premium in the same socket that a Prime was in. With the evaluation kits, there are key interfaces available for system testing. This card could even be dropped into a live network for running whatever code customers need to implement. Prime shares a lot of architectural blocks with Premium. Prime is a subset of Premium, so key architectural blocks can be evaluated. I would expect the NOC, the memory controllers, and maybe the application processors to be evaluated early on. And then we provide a variety of system design methodology guides to help streamline development. Now, over to what's specifically available on Versal Premium. Versal Premium documentation is available now. Tools are scheduled to be available in the second half of this year, in the second half of 2020, and devices are scheduled to start shipping in the first half of 2021. So in summary, Versal Premium is a massive amount of integration. It's breakthrough integration of networked, power-optimized cores on an adaptable platform. It's triple the bandwidth of our previous generation for the fastest, most secure networks. That's up to 9 terabits per second of serial bandwidth with integrated 112 gig PAM4 transceivers. It's 5 terabits per second of integrated Ethernet and up to 1.6 terabits per second of line rate encryption integrated. It's double the compute density for adaptable acceleration. It's the highest logic capacity and DSP density for hardware acceleration. It provides massive memory capacity and bandwidth that eliminates key acceleration bottlenecks. And it's a very highly integrated hardware-software platform for productivity. We have an integrated shell or all the integrated connectivity IP for quick connectivity. Depending on the type of developer, we have Vitis for software developers, application developers, data scientists. And we have the Vivado Design Suite for our traditional customers, hardware developers. This is a complete solution stack for hardware and software developers alike. Silicon is scheduled to start shipping in the first half of 2021, and customers can get started now.